Good morning, good afternoon, or good evening, depending on when you are watching this. So this begins our lesson on fibers and textiles. So today we are going to view the part 1 video and answer some questions. So first thing, fiber, what is it? A fiber is the smallest part of a textile. Fibers are the raw materials that are used to make textiles. So your next question might be, what are textiles? Textiles are basically clothing, carpets, upholstery, any piece of material made of interlacing yarn. Yarns are made up of fibers that have been spun together, and yarn can be thick or thin depending on the garment that you're making. In fact, rope is just a very big piece of yarn. So fibers are used in forensic science to establish a link between a crime and a suspect. For example, a thief might own a jacket made of a material that matches a fiber that's found at a crime scene. Of course, this only means that a jacket like his was at the crime scene. It does not alone prove that he did it. But if the jacket, shirt, and sock fibers all match what the thief owns, then the chances are higher that this suspect was present at the crime scene. As we go about our day, we shed and pick up fibers. They can tell a forensic scientist where a suspect has been and with whom he or she has been in contact with. Fibers are considered to be class evidence because they're not specific to a person. Criminals may wear gloves and try to avoid leaving evidence, but very small fibers are shed unnoticed and can often be important evidence because fibers can come from carpets, clothing, bedding, insulation, or rope, which could link the suspect to the crime. So let's review from Chapter 3, our chapter on hair. What is the difference between direct, which is also called primary transfer, and secondary transfer? And if you just think about what the meaning of the words are, it can help you figure that out. So hopefully we remember, but direct transfer or primary transfer, this is when fibers are transferred directly from victim to suspect or suspect to victim. Fibers get transferred from the fabric of an individual's clothing to the clothing of another individual, much like hair. Secondary transfer is when these same fibers are then transferred to other objects during subsequent contacts. So, for example, if a victim has fibers on his or her person that were picked up from somewhere else and then transferred to a suspect, that's considered secondary transfer. So let's say the victim has fibers from their couch or a blanket that they had on that they own at home, and then it gets transferred to the suspect, secondary transfer. So with fiber evidence, early collection is really important because generally within 24 hours it's estimated that about 95% of fibers may have been lost from the victim or the crime scene. And forensic scientists are not going to look at every single fiber, only fibers that are unexpected. For example, let's say pink fibers are found on the victim's clothes, and the victim lives in a house with wall-to-wall pink carpeting. Well, then those fibers are not going to be examined because they would be expected to be on the victim. Anything that's unique or unusual is what would be looked at. So how do forensic scientists use fibers? There's information that forensic scientists need to gather from looking at fiber evidence. First thing, type of fiber. What is it made of? Is it unique? Is it rare? For example, a white cotton fiber, probably not all that useful since most people have white cotton t-shirts, white cotton socks. An Angora fiber is less common. That would be more useful. The fiber color, the type of dye can be matched, and can we link the suspect and the victim? Two blue textiles can use completely different dyes when we analyze the dyes. How many fibers were found? The more that you find, the easier it is to make a match, and can also indicate more prolonged contact. The location where they're found, are you able to place the suspect at the scene? The textile that the fiber originated from. That would be important. Is it from carpet from a car? Is it from carpet in a home? Is it from upholstery, clothing? A body could have been wrapped inside a carpet and then dumped. That could give some type of evidence. Also, are there multiple fiber transfers? Several types of fibers that link to a suspect can be more conclusive, can definitely suggest a longer contact and a possible pattern of violence. Also, the type of crime committed. Each type of crime has an expected pattern of contact between the suspect victim and the crime scene, and you would expect to find certain fibers. The time between the crime and the discovery of fibers is important. Is it an hour? Is it a day? Is it a week? Unfortunately, the passage of time greatly reduces the effectiveness of fiber evidence. Fibers fall off, unrelated fibers are picked up, unless the fiber location has been undisturbed. For example, an item that was immediately bagged at the crime scene, an item of clothing, or a room that's been completely sealed off and undisturbed. So it's important to be accurate in recording where fibers are found. If it's not accurate or incomplete in the recording, the evidence may be inadmissible in court. So fibers are often found in very small amounts, sometimes maybe a single fiber. So the first task is to gather the fiber, and you can use forceps like tweezers, sticky tape, or vacuums. Vacuums are probably the least preferred method. It's more important to record exactly where you got the fiber. And then the next thing is to identify the type of fiber, characteristics of the fiber, such as the color and shape. Then attempt to match it to the suspect source, like a car or their home or their clothing. And one thing you have to be careful of, when there is only a little bit of evidence, you can't do any tests that are going to damage or destroy or alter the fibers. So, two tests that do not damage fibers are polarizing light microscopy and infrared spectroscopy. Polarizing light microscopy uses a microscope that has a special filter that allows the examiner to look at the fiber using specific light wavelengths. Infrared spectroscopy emits a beam that bounces off of the fiber and returns to the instrument. The way the beam of light changes reveals the chemical structure of the fiber. So these are two tests that you can do that are not going to damage the fiber. Well, that's all for part 1. See you next time.